Today what we're going to do is we look at processing M31. Yep, that's the image you see in front of you. So we're going to go from the masters. We have 4 masters. We have the Luminance with red, green and blue. They've already been shot by a friend of mine. And we're going to take a look at these and try and turn them into an image like you see on the screen. I'm going to use this workflow here. So it's an LRGB workflow. What we're going to start with is crops. We're going to go into gradient removal for all of the different masters. If it's RGB, we're going to follow down the linear fit, channel combination and background neutralization channel. If it's not, we're going to go straight to deconvolution and noise reduction and then move over to a nonlinear stretch. We'll talk about that in a bit, but you've got a pretty good idea from this already what we're going to try and do today. All right, so I'm just going to close this image down. And let's open up the masters. So over to my file system, I'm going to open and I'm going to select the masters I'm looking for. So we have our luminance, blue, green and red. And we're opening them now. Well, as you can see, we selected 4 files and yet we're getting many more than that. In fact, we're getting 3 files per group of 4. So we're getting 12 files up. And these are actually the rejection images grouped together with the masters. And the reason for that is during the WBPP process, there was a tick box actually asking if you wanted the rejection elements on there, and this is one of them. Let's take a quick look though. So I'm just using a Control A, and we can see that we've got some satellite trails and some other things on here. So let's close that one down. Okay, and we have some stacking artifacts. So this should be our first image. Yep, here's Andromeda. And what we're going to do, I think, is we're going to rename this. Is I have many of my processes set up, so pre-populated with the name. So Loom, for example, is important to me. Okay, let's put the Lumens away. And these two are our rejections again. And let's see, this is the red. Let's change it to red. Let's take a look at it just to make sure. Yep, there we go. There's a red. Rejection again. So this is going to be our green. Okay, take a look at it. I think I see quite a strong gradient, which is something we're going to need to deal with because it's much darker here than it is up here. So these are the 2 rejections. Okay, and this is our blue filter. So again, we're going to change its name. Okay, blue, red, and we can put it away. Right. Let's just look at WBPP for a moment. And to know that these images haven't been cropped either. And I think there are 2 things that are worth looking at in WBPP. We can actually do that might help us with our workflows. So I'm going to go to script, batch processing, and weighted batch pre-processing. And we're going to be looking at 2 parameters. Now this is actually my WBPP rather than the one that was used to create these images that we're working on. But the first thing we can see here is rejection maps. And if that is on, we'll get to see them. So rejection maps and the drizzle weights. One of the things that we can do to reduce the amount of work, if we don't want to see the rejection maps, just turn it on. The other thing we might want to think about is in the lights. And if we take a look at this point here, image integration, you see the auto crop. If we have that ticked on, that means that the system will do a crop for us. And when we actually see the masters, what we'll get the cropped masters come out as an additional. So that can reduce the amount of work we might need to do. All right, so I'm just going to come out of here and we're going to carry on going. So let's pull up that flowchart again and see what we're going to do. So we want to crop, we want to do gradient removal before we do anything else. Okay, let's do that. I'm going to close this down again. one of the things I would like to do is I just like to check the size of these files first. So I'm going to go to Process, All Processes, and then go into Statistics. Here's Statistics. And I'm just going to select, no, I don't know, Luminance. There we go. And sure enough, if we take a look at this, this has done this image, or the image, the frames, the original frames are all very 61 megapixels right now. So one of the things I think I'm going to do is, before I start processing, I'm going to reduce the size of these down to, maybe 25% of the size they are right now. How do we do that? Well, we use a process, and it's called resample. And we'll come down here and we'll find resample, and there it is. Now it's not rescale. Rescale is more about the color spaces. So resample is what we're looking for. And you can see that currently it's set at 100%. If we want to get this to 25%, we'll want to do 50 on the width and 50 on the height. So that'll bring it down to a quarter of the size. So we can just type in 50 here. And what you'll see is it changed this one as well to 50. So why is it doing that? Well, preserve aspect ratio, that's clicked on. And if you want to be able to do different sizes, not sure why you would, but you might want to, between the width and the height, then you would click that off. But let's keep that on. So we're preserving the aspect ratio. Now, if we wanted to, we could apply this this resample as usual. Pick up that triangle and drop it straight on the, straight on the image. But one of the things we could do instead is use a little technique that allows us to group the images together. And I'm going to look at the ones that we have available to us in our views. Remember, we've got the red, green, blue, and luminance. I'm going to select all of those. Okay, and now what I'm going to do is I'm going to take that and add it to resample. And it's done. So we close the image. Actually, I'll just iconize that image container for the moment. We might want to use it later, who knows? So how do we know it's done anything? Well, let's take another look. We're going to go to look at process, all process and statistics. If I can find it, there we go. And now we can see our count at 15 megapixels. So it's done their job. Now we could check all the others, but I think you'll find that they're all done the same. Okay, so we're going to close statistics. On with what we need to do. So the first thing we need to do is a crop, because there wasn't a crop done on the originals. And we can actually see that because if we take a look at this image here, you can definitely see an artifact up there. And I believe there's some artifacts down the side here, although that's not quite as visible on here. However, what I'm going to do is I'm going to do a crop first of all. So we need to do the same crop for all of 4 masters. This is the luminance, and we're going to need to do it for the red, green, and the blue. So first thing I usually do is just reduce it in size a little bit so I can see what I'm working with. And then I'm going to pull up my crop. And I'm just going to very gently take the side of that. And there we go with that. Now, before I hit the go ahead button, what I want to do is I want to save this process away, all the parameters. And the reason is because I'm going to apply these same parameters to the, this is the luminance. I'm going to apply it to the red, green, and blue. But we'll give that as a yes. Okay, that's done that crop. So let's open up let's close you down. Let's open up the red, apply the process, close it, open up the green, apply the process, and open up the blue. Apply the process. All right. So we have applied a crop. It's currently called Process 53. If we wanted to, we could rename it. I'll show you how to do that, shall I? So so you right click on the process and you set the icon identifier, and it'll allow you to change its name. So crop Can't use the same name that already exists, and I've already got one. Let's call that crop one, and there we have that icon. Moving on now to the gradient removal. Now, I mentioned that there seemed to be a lot of gradient in this. Yeah, you can really see it here. I'm just going to open it a bit. And so you could use DBE, you could use ABE, Dynamic Background Extractor, or Automatic Background Extractor. I actually like a free piece of software that you can add into as a script into Pixinsight called Graxper, and that seems to me to do a great job of removing gradients. So we'll use that today, and so let's do that. Oh, you might wonder why I decided to resample earlier. Well, one of the things I know is that when we have a very large file, it takes much longer to actually uh, do anything, within on my system. Guess it's getting old, a bit like me, but it's also for me. I couldn't when I processed this as kind of a trial run earlier. One of the things I noticed was it took an awful long time, and I couldn't really see much benefit at the end result. So I quite like the fact it's being reduced in size like this. If you want to keep it the size it was, that's fine. But think about it if your processing is taking an awful long time. Do investigate why your process is taking a long time. It is possible that you've got a very full disk system, and that can happen. And that will slow Pixinsight down quite considerably too. Anyway, on with the job. So Raxper, this is our blue. I'm going to go in the sequence. I have that sequence, Loom, red, green, blue. So I'm going to keep to that sequence now. Let's open up Loom first. And we're going to go to scripts, and we'll find, once you've added Graxpert, we'll find it in toolbox, and there's Graxpert there. Okay, and we're going to say yes, and it goes and does its work. So we have our image, our Luminance image. Let's close that one down. And now we'll do the red. So let's apply Graxpert to it. Now the blue. That really is a strong gradient. It's probably caused by light pollution. I know these images were shot from a suburban front yard, and that's what light pollution does for us. It could be the moon, of course, but in this case, I'm pretty sure it's the street lights that were around the house. Go to script, toolbox, correct, and here we go. All right, so you can see that we've got rid of the gradient. So what we're going to do is just pop up that flowchart again, see where we were. So we've done the crop and the gradient removal. Now we have a choice. We work on the luminance differently to the RGB. So if we work on the RGB stuff first, we'll be going down this path. If we work on the luminance first, we'll come down this path. Let's work on the luminance element first. Okay, so luminance. There we go. What we want to do with this? Well, basically, I want to do some deconvolution, and I'll want to do some noise reduction. Now, I could use a thing called a process container, which is different from the image container. Let me show you that. So you'll find the process container in processes, and then you'll find process container here. Okay, so, and what we can do is we can just add the processes into this. You just pick them up and drag and drop them. That's what we can do. But what I find is when I run it, it sometimes gets tricky to go back to what particular process did. But what I'm going to do first of all is run Blur Exterminator. This is from RC Astro, my deconvolution step. So I'm just going to use it at its standard setting. And here we go. And this is going to take a while, so I'm going to pause it while this is taking place. Well, that took a little over 4 minutes, but here we have the blur exterminator has just finished its job. So it's a deconvolution portion. Let's go and take a look at what it did. So here's our deconvoluted image. This is just going to move to before. Let's actually just expand that out a little bit. There's before, and that's after. Let's zoom in a little bit into the galaxy itself and see what difference it's made here. Okay, so this one is after, and there's before. So it made a little difference there, I think. But what I can see is a lot of noise. Well, the next job is to try and deal with that noise. And we're going to use, again, another product from RC Astro. It's a noise exterminator, and you can use your own noise tool if you know, whichever suits you. So here comes noise exterminator. And again, I'm going to pause this recording while this runs. Okay, then noise exterminator is finished. And that took just under a minute. But we can see the job it's done already. It's definitely improved the speckle. Let's go and take a look at what it was like before. Yeah, and after. Before and after. So let's take a look. Where are we now? So we've come down this track. We've done the deconvolution. We did that with blur exterminator, and we've got noise reduction, and we've done that with noise exterminator. And so really we're heading off down here towards the nonlinear stretches. So I'm going to do the nonlinear stretch on this luminance image before I do anything else. There's multiple ways of doing a nonlinear stretch. You could use GHS. You can use the approach of doing a screen transfer function and applying that to a histogram transformation. You can do that. Or you could use what Bill Blanchard has done. Bill's done some Pixinsight. Bill's done some pixel math, and we can use his approach. And you can see I've got this icon here called Bill's Unlinked Stretch. This is the pixel math, and it's an amazing thing. Just watch. Okay, so we have the usual double stretch. Just reset that, and there we go. I'm just going to go to. So that was the result of Bill's stretch. It was just a single click and off it goes. You may need to change some parameters with that, but go and take a look at Bill Blanchard's um, uh, stretch video, and it's really quite something. All right, we can see that in fact it's stretched because we've lost that green marker on the side there. All right, let's put luminance away. So now we're going to move to the other side of our workflow, which is the RGB side. We could, of course, just do a straight channel combination, but I think what I want to do first is just do a linear fit. Just make sure that the brightness of the image is the same across all three. It really helps, I think, in terms of getting the color right. I actually have my own piece of pixel math. Here it is. And what it does is it looked at the red, the blue and the green images, and it determines which of them has the lowest median value. And we're going to use that for the reference. It then actually creates a file called reference. We can see that here. So let's open that up. So you can see it creates a new image and does a so all this does is choose which of the red, green, and blue is the least bright, and calls that reference. And so all I need to do is apply this. I need to apply it to an image, but it doesn't change the image itself. Okay, so it's created a file called a reference, and we can take a look at it. Okay, so here's our reference file. We can put that one away. So now we can do a linear fit. Now, if we wanted to, remember we have this thing called image container. Well, what we can do here is we can cut the luminance off, and we can run a linear fit on the blue, green, red. First of all, let's go to process, all processes, and look for linear fit. I'm going to put reference in here. I could have already had this set up as an icon with reference already in there if I wanted to, and save that. Okay. And we're going to take these three and apply it to linear fit. So we've just done the linear fit on the red, green, and the blue. They're all done. So now channel combination. All right, so let's take a look. We could just go into channel combination like this, and we could put, pick red in here. We do that. Sure. But on the other hand, we could also have created an icon because we know we're going to call them red, green, and blue, and they're already in here. Let's do that. We're creating a new image, and there we're done. So let's take a look at our combined image. So this is our combined red, green, and blue, and I'm going to just rename this. There we go. And there's our red, green, and blue. Now we do still need to do a bit of work on this. We need to neutralize the background and do some color calibration on this. There's not really one of the things that we're going to need for background neutralization, where what we do is we take the background and we make sure it hasn't got any particular color class. So we're looking for it. We're looking for it to be a kind of a constant, kind of a gray, a neutral gray. That's why it's called background neutralization. All right, so let's just go into this and see if we can find an area we can use as our background reference. Not very many spots, but see, I'm going to just expand this out a little bit more. Okay, I think I can see some areas here. So I'm going to create my first preview in here. Okay, so this is going to be the preview for our background reference. So our background visualization. This is going to be our background reference. So background visualization, we're going to select preview 1. There we go. And we're going to apply it. That's done. Look. So now what we're going to do is go into color calibration. Now, color calibration needs a background reference and it needs a white reference. And so what we're going to do is we're going to select that the preview 1 that we had before, and that's going to be our background reference. Okay. And now we need to put a preview in for the foreground reference, for the white reference. So let's reset all of this. And I'm going to make the galaxy itself the white reference. So I'm picking up a new preview. And that's going to be our white reference. Preview 2. Okay. And we're going to apply it. All right, that's done. So I just would like to do a little bit of more color work, I think. Normally I'd use SPCC to get the colors right on this, but because I don't have the correct catalogs, this is a different camera and telescope combination to what I use. I'm going to use a handy little script called AutoColor, and what this does is it does a kind of a pretty good job of balancing the colors out. So we've finished our color work, I think, at least in the linear state, rather. And I'm going to get rid of these previews. And let's quickly take a look at where we are. So we've done linear fit, channel combination, background neutralization. I also did a little bit of work in here just to improve at least from my perspective, improve the color. And we're going to head down into nonlinear stretch territory. We've already done a nonlinear stretch for the luminance. So now we're going to do the nonlinear stretch for the um, for this image, the color image. And again, I'm going to use one of Bill's pieces of pixel math. This is a link stretch. It links RGB, the red, the green, and blue, and we're going to run that now. So I'm going to take that, apply it, and of course, when this is finished, we've got the big white screen. All we need to do is turn off the background stretch, and there we go. So what do we have? We've got the RGB stretched. You can see we've lost that little green line there. And we have the luminance stretch. We haven't got a line there either. What we're going to do now is we're going to use the luminance combination, the LRGB combination. So this is the luminance, this is the RGB. And remember, most of the detail is within the luminance image. The chrominance, the RGB, is really just color information. But this is what we're going to do. So we're going to put luminance in here. Blue, luminance. Okay. And we're going to apply this to the color image. This one back here, the RGB image. And there we have it. So here we have the LRGB image. Just change its identifier so that we know where we are. LRGB. Okay. And again, let's pull up the workflow. So where are we? So we've done the RGB and luminance combination. Remember, we did that with the RGBC process. And really, I think what we want to do now is do a star mask. And that is that we want to separate the stars from the galaxy. It sounds like I'm an advert for Ask the Astro, but I do like their star exterminator tool. You probably have your own favorite star masking technique. So now what we're going to do is create two images. One is the stars and the other one is the galaxy. So let's go ahead and do that. So for me, process or processes and star exterminator. One of the things I'm going to do is I'm going to pause it after star exterminator runs because it does take, all of these techniques can take a while. So we do want to generate a star image. Yep. And we're going to apply that now. And we're back. So star exterminator took a little while. So let's take a look at that. That's 2 minutes 45 seconds. So that one. All right. So close you down. And I'm going to rename our stars. All right. So we have star. And let's put stars away for the moment. So here's our image of Andromeda. We can see with all sorts of blotchiness around the outside. So let's take a quick look at where we are in the workflow. Pop this up. So we've done the star mask. Are we working on the star image, or are we working on basically the galaxy? So we're coming down this part of the flowchart here. Okay. So we need to create a mask. Now there's a fabulous tool called GameScript, which you can download, and it's free. You can add that to Pixinsight. So I'm going to go and pick that up. It's in Utilities and Game. And this allows us to put a mask in this case an ellipse. So I'm going to add an ellipse. Picking it here. And shaping it a little bit. Shaping it over our object. Okay, so what I've done is I'm creating a mask over the object that I'm interested in. And there's two reasons I want to do this. One is I want to increase the color saturation of our galaxy. The other is I want to tone down all the stuff that's on the outside, all that noise that we saw. So this is our mask. I'm just going to call it mask. There we go. No reason, but just keep that a bit tidier. And we're going to apply mask to the image. So we just drag it. Okay, so Don't close mask, just you can iconize it. Red protects. So in other words, whatever we do now isn't going to be applied to this outside area, this red, deep red area, but it will be applied to this inner area here. And you can see it's graduated, so it's going to have a lesser and lesser effect as we move away from this central piece. Okay. Now, obviously, the red's a bit distracting, so what we can do is we can show the mask. So I'm going to turn that off. Okay, now color saturation is what I want to do next. I'm going to turn on the preview, and this range basically allows me to do a more strong job. Chose 3 or 4. I think 3 is probably enough. There we go. And I'm just going to up the saturation. Now, if I wanted to, I could actually select blue more than anything else, but that looks about right to me. I'm just going to hone this down a bit. There we go. So that's what I'm going to, that's the saturation I'm going to apply. So hit the apply button. Okay, and of course it's double applying it now, it's applying it again, but we all know about that. Okay, so this is the new color saturated version. Let's go and take a look at before and then after. I quite like that. You do this to taste. You might want it more, you might want it less. All right, so what's the other thing I want to do? I want to get rid of all this kind of blotchiness on the outside. So what I'm going to do is go to mask and I'm going to invert it. In fact, let's take a look at it. Let's go to show. And you can see now what it's doing, red protects, so it's protecting this area and it's leaving whatever processes we apply to the outside. So back to mask, and I'm not going to show it, so I don't see it anymore. And now I'm just going to use histogram transformation. It's quite an easy way of doing it. I'm going to turn on the preview. We can see what we're doing, and okay, we can see that we've turned it down. Oh, there we go, about there. Okay, apply it. There's our LRGB image of the galaxy, and now we're going to take away the mask. Move the mask. And a couple of things I think I want to do. One thing I'm going to do is I'm just going to do a little bit of dark structuring part, I think. So the script, go to utilities, and dark structure enhance. Let's find that. Like this. I like to bring out the dust lanes in Andromeda particularly. Pleases me a lot. I think I see a little bit of green there. So I'm just going to do a bit of SCNR on this. This is a noise. This will basically take out the green color. So let's use SCNR. Let's find it over here. And I'm going to apply that. Okay. All right. So here's our galaxy image. Now what we want to do is we want to work on the stars. Now what might we want to do with the stars? Let's open them up. Well, I think what we want to do is just reduce the impact of the stars, and maybe, you know, on that final image, it was very, very busy with the stars. You might decide that you like them in, that's fine. My particular preference is to reduce the impact of those stars. So I'm going to use a morphological transform, created, and I'm simply going to apply it to the star. There we go. And close that. Now we need to add the two together. I particularly like James Lamb's approach for adding stars back into the image. So it's a piece of pixel math. If you go onto his site, you'll find it, and you can just brilliant channel he has. To do now is we're going to add these stars back in. It's as simple as doing that. And there's our stars. I think one of the things I'm going to do though, actually, let's find that LRGB image. Okay, I'm just going to close that. Yep. And I'm going to take that image and call that LRGB, identifier as LRGB. All right, I'm going to close my style down. There we go. I think what I might do is a local histogram equalization on this. It would just improve the contrast just a little. So let's do that, local histogram equalization. Fortunately, this process doesn't take very long, so that's that done. Let's take a look at the before LHE and after LHE. So very slight difference. And there you have it. So this is our LRGB image of Andromeda. If you want to see about saving it, so don't forget that if you want to, show it to people, save the image, you need to save it as a JPEG or some other form. But a JPEG image makes it so that you can actually share it with folks on social media and such places. The ISF is what Pixinsight uses. So if you want to do more work on it, do it in that format. Okay, so with that, I'm going to say thank you for joining me today. Just pull up the workflow again, and I hope you found this interesting. Talk to you soon. Bye for now.